Good morning, dear students. So my name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today we have selected paper 1 of this subject. And for this purpose, we have taken May-June 2024 1-2 paper. This paper 1 belongs from the Zone 2. In this paper, I'm going to present you the solution of this paper. The very important thing is the paper and the marking scheme which I have used in this video are the property of the Cambridge Assessment International Education. So let's start today's paper, and here we go. So on your screen, the paper May-June 2024 1-2 paper is showing up. The time allowed for this paper is 1 hour. And there are 40 MCQ questions, and we have to select the correct options out of given 4 options. So let's see question number 1 on your screen. What is measured using a micrometer? The micrometer is used to measure length. It is basically used to measure the diameter. The diameter is basically a length. So I think question number 1, I think C is the choice. Let's check from the marking scheme. Question number 1, we think that is the C choice. Question number 1, yes, sir. Question number 1, C is the right choice. Question number 2 showing up on your screen. He says two people pull on ropes to move a boat along a canal. So these are 2 people. They are pulling this boat along this canal. The boat moves at a constant velocity. The vector diagram of for the tension in the ropes is shown. Which vector is the drag acting on the boat? Okay, so what I will do, I will complete the parallelogram. And when I will complete the parallelogram, then I will be able to find out what is the. So parallel to this, I will draw a line here. I'm going to use the parallelogram law. So parallel to this, I will draw a line. Parallel to this, I have drawn a line here. Parallel to this, I will draw a line here. I'm using the vector addition by the parallelogram law. So then the resultant vector will be where the tails are joined. When you use parallelogram law, you put the vectors in such a way that the tails are joined together, and then you complete the parallelogram. You suppose that these 2 vectors are the adjacent sides of a parallelogram. And you complete that parallelogram, and where the tails are joined, you join that point with the opposite corner of the parallelogram. And that is your resultant vector. So the resultant vector should be in this direction. So therefore, which vector is the drag acting on the boat? That is the resultant force of those 2 forces. We think B is the choice, sir. Question number, sorry. It's question number, what is the question number? Let me check. This is question number 2. Therefore, the vector diagram for the tension in the ropes. Which vector is the drag? Okay, so this is the resultant force. This is the resultant force with which the boat will be moving. And because the boat is moving at a constant speed, so the drag force is opposite to your force. The resultant force is this way. Drag will be exactly same, but opposite in direction. Drag is the friction of the water, and that will be opposite to the resultant force acting on that boat. Okay, their question is, which vector is the drag acting on the boat? First of all, with the help of the parallelogram law, we found what is the resultant force of those 2 forces, and the boat is moving with that force in the forward direction. Because the boat is moving at a constant speed, so the frictional force and the forward force, they will be equal to each other. So that's why the drag of the water, which is the friction of the water, that will be opposite to your motion. So its direction will be according to this green vector. Just forgive my diagram, my drawing, because I am drawing it with the help of. This is a tricky question, a little tricky question. He did not just ask you to find out the resultant force. He asked you to find out the drag of the water. The drag of the water is equal in magnitude to the resultant of the two tensions in those ropes, and is opposite in the direction to the motion of the boat, because the boat is moving at a constant velocity. You can see here they use this word constant velocity. So I hope you understand question number 2, and its choice will be A. Question number 2 choice will be A. First of all, I thought they are simply asking you the resultant force. Okay, so you see, we have to read that question, always read that question carefully and read those statements, all the statements of that question. Okay, so here we have question number 3 coming up on your screen. The graph shows how the speed of a car traveling in a straight line changes with the time. Which section shows the largest acceleration? So it's a speed time graph. You know, the gradient of the speed time graph is equals to the acceleration. Wherever the gradient is steepest, wherever the gradient is largest, in that portion, the acceleration is the largest. If you look at here with the simply without any calculation, I can say that in the portion A, the gradient is largest. So I think the acceleration is largest in the section A. Question number 3, section A is the right option, sir. In the speed time graph, you know, the gradient is equals to the acceleration. The question is, where is the largest acceleration? So wherever there is the largest gradient of that speed time graph, there you have the largest acceleration. So the choice is A. So next question coming up on your screen is question number 4. A man walks along a path from X to Y. The diagram shows the path from above. The man measures the distance he walks and the time taken. Which quantity can be calculated using this data only? So if you have distance and you have time, so we can find out the average speed. The average speed is equal to the total distance traveled divided by the total time taken. So I think question number 4, average speed B should be the answer. Question number 4, B is the right answer, sir. Question number 4, I hope is clear. Question number 5 coming up on your screen. Which property of an object determines its resistance to a change from its state of rest or motion? This is a very famous property of anybody who has mass. We call it inertia. And inertia is the opposition to the state of and any change in the state of motion. So if a body is at rest, it tries to remain at rest. If a body is in motion, it tries to remain in that motion. So we call it inertia. Inertia depends upon the mass. And do we have in option the name inertia? No. In the options, we only have the name mass. So you can use, instead of using inertia, you can use the name mass. It's a property of the mass that it resists any change in its state of motion. So question number 5, we call this property inertia, but the word inertia is not given in the options. So I think question number 5A is the option, sir. That is the right option. So we are going to the next question. The next question coming up on your screen is question number 6. So question number 6 says that the diagram shows a moon buggy used by astronauts. The mass of the moon buggy on the Earth is 210 kg. The gravitational field strength on the moon is 1/6 of that on the Earth. What is the weight of the moon buggy on the moon? You see, if the mass of that moon buggy is 210 kg on Earth, its mass will remain the same on the moon. The mass do not change when you go to the moon. So on the moon, the mass will be 210 kg. The G value, the gravitational field strength of the moon, is 1/6 of the Earth, that on the Earth. So the gravitational field strength on the Earth is 9.8 Newton per kg. So multiply 1 by 6 with the 9.8 Newton per kg, and you will get the gravitational field strength on the moon. And once you know that, so we will be able to find out that. I have done this numerical. Let me show you. I hope this is showing up on your screen. And let me. So here we go. So question number 6, the solution is showing up. The the weight is equals to mg, the mass is 210 kg, the g value on the moon is 1 by 6 of the 9.8. Just do this calculation on your calculator. 210 multiply 9.8 divided by 6, that is 343 Newton. So when you round it off to two significant figures, it will be 340 Newton. 340 Newton. Let's check. Do we have this number in the options? And 340 Newton. D is the option, sir. D. Question number 6. D is the option. Our answer is right. And I can show you again. This is how this is done. D is the right option. Okay. So then we have question number 7 showing up on your screen. A car travels along a road. The force on the car due to the engine is 800 Newton. The motion of the car depends on the value of the total resistive force R. Which row shows the motion of the car for the given value of the R? So you see, value of the resistive force is given. The forward force is 800. If the forward force is 800, the resistive force is 500, then you will have a resultant force in the forward direction of 300 Newton. I'm subtracting the forward force minus the resistive force. Then, because the resultant force will be in the forward direction, so the car must be accelerating. In the B option, the forward force is 800 Newton, the resistive force is 800 Newton. When you subtract them, you get the zero resultant force. When the resultant force is zero, the body should be at its acceleration must be zero. It should be moving with a constant velocity. In the C option, the resistive force is 900, the forward force is 800 Newton. And so the resultant Newton in the backward direction. If the resultant force is opposite to your motion, then that car should decelerate. So C looks the right answer, sir. And then at the end, he says 1000 Newton resistive force, 800 forward force. Then you will have a 200 Newton resultant force in the backward direction, opposite to your motion. Then the car must be decelerating. Here they have written acceleration, which is wrong. So C is the right option, sir. Question number 7, C is the right option. Question number 7, C is the right option, sir. I hope you understand this. Question number 8 is showing up on your screen. 4 of the gravitational forces that act between objects in the solar system are listed. The force on the moon due to the earth, the force on the earth due to the sun, the force on the earth due to the moon, and the force on the earth due to the moon, the force on the moon due to the earth. Okay. And the S part is the force on the moon due to the sun. Which two forces are of Newton's third law pair? Okay. You see, whenever we talk about the Newton's third law pair, forces which are the Newton's third law pair, these are the two forces which are between two bodies. One force acts on the body A, the other force acts on the body B. For example, what do I mean? If the body A will exert force on the body B, the body B will exert force on the body A. So the names should be same in both the statements. Okay, a force on the moon due to the earth, P, and the force on the earth due to the moon. Here the names are same. Moon is applying force on the earth is applying force on the moon. So they can be a pair P and R. B looks the good answer, sir. If you talk about the Q and the S, the force on the earth due to the sun. Now the sun is applying force on the earth, but the S statement is the force on the moon due to the sun. So here, if the sun has applied force on the earth must apply force on the sun. If the moon has applied force on the sun, and the sun should apply force on the moon, then it will be a pair. So the right option is P and R, where the moon applied force on the earth, earth applied force on the moon. So P and R, I think B is the right answer, sir. Question number 8B is the right answer. I hope you understand this. Question number next is question number 9 coming up on your screen. And the question number 9 is a box. A box is moved up a rough slope from X to Y. The diagram shows four forces acting on the box. Which force is the force due to the friction on the box? You see the box is moved up. So the box is moving up on that slope, on that ramp. So the friction is always opposite to your motion. If the ramp is going up along that ramp, then the direction of the friction will be opposite to your motion. It will be downward on that, along that ramp. So I think C is the option, sir. Question number 9, C is the right answer, sir. Okay, so we are on the next question. That is question number 10. He says the graph shows how the extension of 4 different threads depends on the load attached. Which thread is the most difficult to stretch over the range of loads shown? It's a very simple question. You see, on the y-axis, the extension is given. On the x-axis, they have given you the, you know, they have given you the load, and let me show you. So what we will do on any load, let's say I take this load. Suppose I take this load. So on this load, I can go up, 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 up. So you see in the body A, this much extension has produced. In the body B, this much extension is produced. In the body C, this much extension is produced. And in the body D, I think this much extension is produced. So for the same load, when you apply it to A, B, C, and D, and the extension, the maximum extension is produced in the A, then B, then C, then D. So their question is, which thread is the most difficult to stretch over the range of the loads? I think the most difficult to stretch is D. Question number 10, D option. The most difficult to stretch is D. Question number 10, D is the right option, sir. You can see in the marking scheme. I hope you understand this idea. So let's move to the next question. The next question coming up on your screen is question number 11. A satellite orbits a planet in a circular path as shown. It has constant speed. There is a force on the satellite due to the planet. In which direction is the force on the satellite when it is in the position shown? Usually whenever you are orbiting a planet, we suppose that you are moving in a circular orbit around that planet. So whenever you move in a circular orbit, a resultant force is acting on you, which is always directed towards the center of that circle. So the force at that position where the satellite has been shown, the direction of the force should be toward the center of that circle. So the right option will be B, because it should be directed towards the center of that circle. So I think D should be the right answer, sir. 11D is the right answer. Whenever you move in a circle, suppose on this location, at this position, the satellite, that body should be having a resultant force whose direction is always towards the center of that circle in which that body is orbiting. So the position which the satellite is right now, the direction of the resultant force must be towards the D, centripetal force, sorry. Question number 12. So we think D is the choice. Question number 11D is the right choice. Question number 12 is coming up on your screen. He says a crane has a 5,800 Newton counterweight position 2.3 meter from the tower along a horizontal jib. The center of the gravity P of the crane jib is marked. So this is the center. So here we have this 2,300 Newton weight hanging, and center of the gravity is marked here, P point, and this is also the pivot. And here we have a counterweight of 5,800 Newton. So their question is, what is the horizontal distance between the 2,300 Newton load and P so that there is no moment about the P? I mean the clockwise moment and the anti-clockwise moment. They are basically balanced here. So basically what will happen? This is trying to produce an anti-clockwise moment about this pivot. This is trying to produce a clockwise moment about this pivot. We want to know how much is the perpendicular distance between the pivot and the line of action of the 2,300 Newton. So it's a very simple question. That anti-clockwise moment is equal to the clockwise moment, and we will be able to solve this very easily. Let me show you the moment arm for the 5,800 Newton. We know that that is 2.3 meter. The moment arm, the 2,300 Newton is question. So anti-clockwise moment is equals to the clockwise moment according to the principle of the moments. And 5,800 multiplied 2.3 is equals to the D multiplied 2,300. And so D will be equals to 5,800 multiplied 2.3 divided by 2,300. And that will be 5.8 Newton, 5.8 Newton. I think C is the choice, sir. Question number 12, C is the choice. This is how this numerical is done. This is the simplified diagram of that situation. So I hope this question number 12 is clear to you. Very simple, straightforward, academic type of question. Straightforward, simple question. Okay, question number 13 showing up on your screen. A car of mass 750 kg travels 400 meter at 25 meter per second. At this, it then accelerates to 35 meter per second and travels a further 400 meter. What is the change in the momentum of the car due to the acceleration? Okay, so we know the initial velocity, we know the final velocity, we know the mass of the body. We can find out the change in the momentum. You know, the momentum is the product of the mass and the velocity. Their question is, what is the change in the momentum of the car? The change in the momentum is the final momentum minus the initial momentum. And you know, M1 is 750 kg, V1 is 25 meter per second, M2 is mass is still 750 kg, and V2 is 35 meter per second. So change in the momentum is the final momentum minus the initial momentum. So MV2 minus MV1, 750 multiplied 35 minus 750 multiplied 25, and that will give you 7,500 kg meter per second. 7,500 kg meter per second. I think A is the option. Question number 13, A is the right option, sir. This is how this question is done. The initial velocity is given, the final velocity is given, and we know the mass of that car, and we can find out the change in the momentum very easily. I hope you understand. Now we are going to the next question. That is question number 14. So here we have question number 14. He says a ball is dropped from rest at the top of a building and air resistance is negligible. The velocity of the ball is 14 meters per second when it hits the ground. What is the height of the building? It's very simple. There is no air resistance. So whatever was the gravitational potential energy at the top, the same gravitational potential energy, the whole of that gravitational potential energy will be equal to the kinetic energy gained when the ball is about to hit the ground. So the loss in the gravitational potential energy will be equal to the gain in the kinetic energy during that drop. So loss in the gravitational potential energy is equal to the gain in the kinetic energy. This stands because there is no air resistance, so there is no loss of the energy. mgh is equals to 1 by 2 mv square. So m and m will be cancelled from both the sides. So gh will be equals to 1 by 2 v square. So the h will be equals to v square divided by 2g. Now we know the initial velocity with which the, sorry, I said initial velocity. We know the velocity with which it was going to hit the ground, that is 14 meter per second square. So 14 square divided by 2 divided by 9.8, and that is 10 meters. So that means the ball has been dropped from the 10 meters. So we think B is the option. Question number 14, B is the option. Question 14, B is the right option, sir. So it's very simple concept that when there is no air resistance, whatever was the gravitational potential energy on the top, it will be equals to the kinetic energy when the ball is about to hit the ground. The loss in the gravitational potential energy is equals to the gain in the kinetic energy. And we don't need mass because both these quantities will have mass and the mass will be cancelled out. And this is how this is done. I hope you understand. Question number 14, B is the right option, sir. Next question coming up on your screen. Question number 15. Which energy source is available constantly over a 24-hour period? Natural gas. Yes, that is available. A 24-hour. Solar cells, no. Tidal, no. Wind, no. They are not available. Tidal and wind, during the day, they can change. Solar cells, and that energy also changes. When the sun goes down, that is not available. Natural gas is a fossil fuel, you can say, and it's available 24/7. Okay, so I think question number 15A is the right options. Next question. Question number 16. A 15-watt lamp is turned on for 30 minutes. The power of the lamp is given, the time is given. It weighs 7,000 joule of energy. What is the efficiency of the lamp? Okay, so first of all, I can calculate the input energy. The power of the lamp is given and the time is given. If you multiply power and time, you will be able to calculate the energy. From that input energy, subtract the wasted energy, you will get the useful output energy. The efficiency is equals to the useful output energy divided by the total input energy. Let me show you the calculation. This is question number 16, and let me show you how this can be done. So here we go, question number 16. The power is 15 watts, the time is 30 minutes, but the time should be taken in seconds. So for that purpose, I will multiply it with the 60, 30 multiplied 60, that is 1800 seconds. Wasted energy is given, that is 7,000 joules. Input energy is equals to power multiplied time, 15 watt multiplied 1800 seconds, that is 27,000 joules. Useful output energy will be equals to the input energy minus the wasted energy. The input energy is 27,000 joules minus wasted, sorry, input energy is 27,000 joules. From there, subtract the 7,000 joule. So you will have 20,000 joule useful output energy. Efficiency is equals to the useful output energy divided by the input energy, multiply 100. You don't need to write here 100. So 20,000, which is the useful output energy, divided by the 27,000, which is the input energy, and your answer will be 0.74. So the efficiency is 0.74. The efficiency is 0.74. So I think D is the option, sir. Question number 16, D is the right option. So let me show you that solution once again. So let me reduce the size so you can see the whole question together. Okay. So this is how this numerical situation has been done. So I hope you understand this. So next question on your screen is question number 17. Which quantity is not measured in joules? Gravitational potential energy, that is measured in joules. Latent heat. Latent heat is not measured in joules. And power is measured joules per second. Work is measured in joules. So their question, latent heat is the amount of energy. Yeah, latent heat is also measured in joules. The specific latent heat is measured, its unit is joules per kg or joules per gram. Sorry. Gravitational potential energy, that is energy, pure energy, that is joules. Latent heat, that is amount of energy needed to change the state of a substance. That is also measured in joules. Don't confuse it with the specific latent heat. Okay, specific latent heat, its units are joules per gram or joules per kg. Don't confuse the latent heat with the specific latent heat. So gravitational potential energy is measured in joules. The latent heat is measured in joule. Power is measured in joules per second, and the work is measured in joules. So which quantity is not measured in joule? That is the C part, power. Its unit is watt, which is joules per second. 17C is the option, sir. 17C is the right option, sir. I hope you understand. Don't confuse the latent heat with the specific latent heat. Okay, latent heat unit are joule. Which description of a liquid is correct? Fixed shape, liquid do not have fixed shape. A cannot be the answer. Fixed shape, B cannot be the answer. Variable shape, yes. Fixed volume, that is true. The liquid has fixed variable shape, but its volume is fixed. So I think C is the answer, sir. D is variable shape and variable volume. The volume of the liquid is not variable. The volume of the liquid is fixed, but its shape is variable. So I think C is the right option, sir. Question number 18. C is the right option. Okay, question number 19 coming up on your screen. Here we have a transparent box has a dividing wall in its middle. It contains two different gases, one in each half as shown. So here we have a dividing wall. Here we have a colorless gas. Here we have a brown gas. It's kind of some kind of box which is transparent. The dividing wall is removed. The box is left for a long time. The gases do not react. What is then seen in the box? So when they will diffuse into each other, so what will happen? This is their question. Okay, so what is then seen? Brown gas on the right and the colorless gas on the left. Pale brown gas throughout. I think when they will diffuse into each other, the brown color, I think its color should become a little faded, pale brown. Okay. Several distinct clouds of colorless and brown gas throughout. No. Colorless gas on the right and the brown gas on the left. So the gases normally move from their higher concentration towards the lower concentration. So basically what happens, brown gas and the colorless gas, they will kind of mix with each other. They will diffuse with each other. And I think the pale brown gas throughout the color should not remain that dark, okay? Because the brown colorless gas is colorless, but the brown gas, because it is a smaller volume, then it will have a larger volume. So the color should become a little pale. I'm not sure, but I think B should be the answer. Question number 19. So let's hope our answer is right. I'm not sure. Question number 19. I think B is the option. Question number 19. B is the right option, sir. Question number 19. B is the right option, sir. Question number 20 showing up on your screen. He says a bottle containing a cold liquid is placed on a table on a warm day. Okay, drops of water form on the outside of the bottle. Which process causes the drops to form? You see, if the bottle is cold and you put it outside, in the air we have water vapors and they are in the gaseous form. When they come in contact with the outer skin of the bottle, what happens, because the outer skin is cold, so they start condensing on the surface of the bottle. So you see those water droplets outside that cold bottle. Which process causes the drops to form? Condensation. Condensation. I think A is the right option. So question number 20, A is the right option. Question number 20, A is the right option. So let's go to the next part. Question number 21. What is the specific heat capacity of a liquid? You know, the specific heat capacity means the amount of heat required to raise the temperature of a body of unit mass through 1 degree centigrade. And, and that unit mass can be 1 kg, it can be 1 gram. So the difference between the boiling temperature and the melting temperature, no, that is not right. The energy required to change the state of 1 kg of the liquid. It is not about the state of change. It is all about the change in temperature. The energy required to heat 1 kg of the liquid through 1 degree centigrade, it is the perfect definition. The energy required to heat 1 kg of the liquid through 1 degree centigrade. C is the exact definition of the specific heat capacity of a liquid. The increase in temperature of liquid when it is heated. C is the right option, sir. Question number 21. C is the right option. Question number 22 is showing up on your screen. He says, which statement about infrared radiation is correct? Infrared radiation is part of the electromagnetic spectrum. They are transverse waves. They are electromagnetic. They do not require medium to travel. In a vacuum, infrared radiation travels at the speed of light. That is true. All the magnetic waves travel at the speed of the light. So I think A is the best option, sir. It's the right answer, I think. It's a 100% correct statement. Infrared radiation is a longitudinal wave. That is wrong. Infrared radiation has a higher frequency than ultraviolet radiation. That is also wrong. Which white surfaces are better emitter of infrared radiation than the black surfaces? That is totally wrong. A is the best option, sir. Question number 22, A is the best option. I hope you understand. Question number 23 coming up on your screen. Question number 23, sir. The speed of sound in the air is 330 meters per second. Which sound is classed as ultrasound? We think that the ultrasound does not depends upon this. Ultrasound will also have the same speed, and ultrasound, we differentiate the sound from the ultrasound. The ultrasound is differentiated from the rest of the sounds on the basis of its frequency. The sound wave whose frequency is more than 20,000 hertz is known as ultrasounds. A sound with a wavelength of it does not have anything to do with the wavelength. A sound with a wavelength of 25 centimeters, a sound with a wavelength of 2.5 centimeters, none of the above. I think none of the above. In our textbook, in O levels, we have differentiated the ultrasound on the basis of the frequency. If the speed and the frequency is given, I can calculate the wavelength as well. But this was question number 23. Let's check. Question number 23, D is the right option, sir. You see in our course, O levels physics 5054, we have never talked about the wavelength of ultrasound. We can calculate the wavelength of the ultrasound, but the how you differentiate ultrasound from other sounds, that is on the basis of its frequency. The sounds whose frequency is more than 20,000 hertz, they are classified as ultrasound. So I think A, B, C all are wrong. So none of the above. D is the right option. So we have already checked the answer. Question number 23. Okay, now we are on the question number 24. Which diagram shows how light from a distant object forms an image in a normal eye? You see, from a distant object, the lens in your eye is a convex lens. So when those light rays passes through your lens, the lens of your eye, it converges them. And in a normal eye, it is perfectly converged on the retina. So it should be perfectly converged here on the retina. I think A is the option. A is the option. So question number 24, A is the right option. Okay, straightforward, simple question. The color of visible light is related to the wavelength of the light. Which list of colors is in order of increasing wavelength? Increasing wavelength. Okay. So try to remember this thing. You know the colors. So, okay. So here, if I write it like Vibgyor, red has the longest wavelength, and then the yellow, orange, yellow, green, blue, indigo, violet. In our country, we call it Roy G. Biv. Roy G. Biv. So when you go in this direction, the wavelength is decreasing. So they say the smallest wavelength, then the larger wavelength, the further larger wavelength. So the blue should come first, then we should have the green, then yellow, and the red will have the longest wavelength. Red will have the longest wavelength. So I think blue, green, yellow, red. Blue, green, yellow, red. A is the right option. Order of increasing wavelengths. The last one should have the longest wavelength. I think question number 25A is the right option. So very simple. You have to remember this code word Roy G. Biv. And as you move from red to uh, violet, the wavelength is decreasing. Just write on a paper. And their question is not this. Their question is start from the smallest wavelength and go towards the longest wavelength. So red will have the longest wavelength of all. So 25A is the right option, sir. Then we are going to the next question, and the next question coming up on your screen is question number 26. He said a thin converging lens is used as a magnifying glass, which row gives the nature of the image produced by an expression that is the linear magnification. When we use a convex lens as a magnifying glass, the object must be placed within the focal length of the magnifying glass, then the image formed is a virtual image, it's a magnified image, it's an erect, or you can say it's upright image. And so the image in the magnifying glass is virtual. And the expression for the linear magnification is the height of the image divided by the height of the object. So image length divided by the object length. So I think C is the right answer, sir. The image is virtual, and the expression for the linear magnification is the image length divided by the object length. So I think C is the option. Question number 26, C is the right option. Question number 27 coming up on your screen. Which application is not a use for ultrasound? Cleaning jewelry. Ultrasound is used for the cleaning jewelry. Scanning an unborn baby. Yes, very famous word, ultrasound, that is used to scan the fetus. Sonar, for the sonar, we use ultrasounds. Sterilizing water, no. Ultrasound is not used for sterilizing water. Question number 27. I think D is the right option. So very simple, straightforward question, nothing difficult in it. Question number 28 coming up on your screen. He says, which equation is correct for potential difference? Potential difference. Okay. A potential difference is equals to the work done divided by the charge. It's a very famous question. It's a very famous, the formula. So the potential difference is equals to energy carried by the charge. Energy divided by charge. It's the definition, the basic definition of the potential difference. So it is basically energy divided by charge, or you can say work done divided by charge. So I think question number 28C is the option, sir. Question number 28C is the option. That is the very definition of the potential difference. The amount of work done to move unit charge, work done divided by the charge. Okay, so we have next question. That is question number coming up on your screen. Question number, okay. Question number 29, sir. The diagram shows 5 electrical circuits. All of the resistors shown are identical. Which circuit will have equal resistance? So which of them will have equal resistance? Okay. So here these two have parallel resistors. Okay. These two are also parallel. These two are also parallel. These two are in series. So 1, 2, 3, they are same. This is not same because they are connected in series. And these are also parallel to each other. So I think 1, 2, and 5. Here, the two resistors are connected parallel to each other. 1, 2, 3, and 5. 1, 2, 3, and 5. A is the option. The fourth one, there the resistors are connected in series. So 29. 29. A is the option, sir. Question number 29. Question number 29A is the right option, sir. Question number 29A is the right option. It's a little easy question. Question number 30 showing up on your screen. Which electrical appliance uses the heating effect of the electricity? A cell phone, mobile phone, a fan, a hair dryer. Yes, a hair dryer uses the heating effect. A lawnmower, no. A hair dryer, in the hair dryer, we use the heating effect of the electricity. C is the right answer, sir. It's a very simple, straightforward question. Nothing difficult in it. Question number 31. He says, how many kilowatt hours of energy are used by 1,000 watt water heater connected to a 230-volt supply for 30 minutes? Okay. So the power and the time. So the power we know, the time we know, and the kilowatt. If you want the energy in the kilowatt hours, so that is power multiplied time, but the power must be in the kilowatts, and the time must be in hours. Okay, the time must be in hours. Okay, so let me show you. I have done this on my So here we go. So the power is given, that is 1,000 watt. I will convert this in the kilowatt. So to convert the watts into kilowatts, you have to divide with the 1,000. So the power is 1 kilowatt. The time is 30 minutes. The time must be converted into hours. In the kilowatt hour, the time is taken in hours. So 30 minutes divided with the 60, you get 0.5 hours. So the energy will be, the electric energy will be power multiplied time. The power is 1 kilowatt and the time is 0.5 hour. Just multiply them, you will get 0.5 kilowatt hour. 0.5 kilowatt hour. B is the right option, sir. I think B is the right option. Question number 31, B is the right option, sir. This is how this is done. And electric energy, to calculate that power multiplied time, the power must be taken in the kilowatts and the time must be taken in hours to get the energy, electric energy in the kilowatt hours. Question number 31, B is the right option, sir. Okay, so we are on the question number 32. Which safety precautions must be taken when wiring an electrical kettle that has a stainless steel outer casing? Its outer casing, any machine whose outer casing is made of metal, the outer casing must be connected with the earth wire, with the ground wire. Our earth wire, ground wire is the same thing. Its outer casing must be connected to a ground wire or earth wire, and there should be a fuse in the live wire. It must be earthed and have a fuse in the live wire, sir. A is the 100% accurate answer, I thing. Question number 32A is the right answer, sir. Okay. So we are going to the next question, that is 33. What is the purpose of the earth wire in a plug connected to an appliance? To complete the circle so that the appliance works? No. To conduct the thermal energy so that the appliance does not get too hot? No, no. To prevent a person getting shocked? That is one reason why we use earth wire. And to prevent the appliance from a current that is too large? That is also true. So what is the purpose of the earth wire in a plug connected to an appliance? To prevent a person getting a shock, to protect the appliance. C is also right. D looks also right. To protect the appliance from a current that is too large. C is the best option, sir. For too large, we need to put a fuse with the earth wire also. So if we are only talking about the earth wire, then its purpose is to prevent a person from getting a shock. I think question number 33C is the right option. I think question number 33C is the right option, sir. There was a little bit confusion between the C and D, but when you think more clearly and you pay more attention, you will understand that the earth wire will prevent a person from getting a shock. A fuse will be used to protect the appliance from a current that is too large. 33. C is the right answer, sir. It was a little confusing. Okay, so we have the diagram shows a wire carrying a current in a magnetic field. What is the direction of the force on the wire? So you can use your left hand. What is the direction of the... So this is a current carrying wire, and the current is going towards the top of the screen, and the magnetic field is going towards let me open my camera so I can show you how to use the right hand. Okay, so where is that thing went somewhere? So where is that camera thing? I just opened the camera, but I cannot see it. Where is that? Where is the camera? Let me. Okay, I am not able to find where that camera thing has gone. So just forget it. Okay. Okay. Let me. New desktop. I am not. I don't know. I just wanted to show you how this left-hand rule thing is used. Okay. So I'm sorry. I just took some time. So use your left-hand rule without this. With my video, just stretch the thumb and the middle finger and the index finger. Index finger mutually perpendicular to each other. Your thumb is the force, and your index finger is along the magnetic field, and your middle finger should be in the direction of the FMC. Okay, your thumb should be the force, okay, and we don't know the direction of the force, and your index finger should be along the magnetic field, and your middle finger should be along the current. And when I use my left hand, my thumb is pointing into the screen. That means the force should be into the screen. So you see, we are using left hand rule. The thumb is showing the direction of the... So I think C is the option. Question number 34, C is the option. In this question, I am using left hand rule. Okay. In the left hand rule, when you stretch the thumb, the index finger and the middle finger mutually perpendicular to each other, your index finger should be along the magnetic field, and your middle finger should be along the conventional current. Then the thumb of your left hand will be pointing in the direction of the force experienced by that current carrying conductor. My thumb is pointing into the screen, so that means into the page. 34. C is the right option. I hope you all know how to use the left hand rule. Okay, so here we have the next question. The question is 34. Sorry, 35. We are done with the question number 34, I think. I just got distracted. Question number 35. The diagram shows a simple DC motor. What is the part labeled Q? In the motor, this part is called split ring commutator. Split ring commutator. Split. I think D is the option, sir. Question number 35. Question number 35, sir. D is the right option. Okay, so it's a very famous, straightforward. There is no difficulty in this. Here we have question number 36 coming up on your screen. Okay, so question number 36. The diagram shows a transformer. Okay, so here we have a primary coil, you can see, and this is the secondary coil. In the primary coil, the number of turns are more. In the secondary coil, the number of turns are less. So that means it's a step-down transformer. So our student writes 4 statements about how the transformer works. And in the primary coil, we always introduce alternating current. And so there's a magnetic field created on the primary coil. Its magnetic lines pass through this iron core, and they pass through this secondary coil. And because of the alternating current in the primary coil, this magnetic field which is created on the primary coil, its magnitude and direction is periodically changing. So that means the magnetic flux which is passing through this secondary coil, that is also changing. So because of that changing magnetic flux, what happens in the secondary coil, alternating EMF is also induced. This is the basic principle of your transformer. A student writes 4 statements about how the transformer works. An alternating voltage across the primary coil induces an unchanging voltage across the secondary coil. No, you provide alternating current in the primary coil, and alternating current is induced in the secondary coil. An alternating voltage across the primary coil produces a changing magnetic field in the iron core. Yeah, a changing magnetic field in the iron core induces an alternating voltage across the secondary coil. That is true. An unchanging voltage across the primary coil is provided with the alternating. So 2 and 3 is the right answer, sir. Which statement explains how the transformer 2 and 3? 2 and 3 are the right statements. 2 and 3. So what is the option, sir? 2 and 3, C is the option. Question number 36, we think C is the option. That is right, sir. I hope you know that an alternating voltage across the primary coil produces a changing magnetic field in the iron core. The changing magnetic field in the iron core induces an alternating voltage across the secondary coil. This is the basic working principle of that transformer. So 2 and 3, C is the option. I hope you understand. Question number 37 is showing up on your screen. The question is, which particle has the smallest mass? Alpha particle? No. Electrons? Yeah. Neutron? It's like proton and proton. Okay. So the smallest of all these is electron. Question number 37. Electron. 37. I think B is the option, sir. Question number 37. 37. B is the right option. Question number 37. B is the right option. Question number. Then we have question number 38 coming on the screen. Which two atoms are isotopes of the same element? So isotopes of the same element will have the same number of protons. Isotopes will have the same number of protons. So it should be 2 and 4. C. C, because they have the same proton numbers. 2 and 4. C is the option, sir. 38. C is the right option. Next. Question number 39. 4 types of ionizing radiations are listed. Alpha particles, beta particles, X-rays, gamma rays. Okay. So their question is, which type of radiation can be emitted from the unstable nuclei of a radioactive material? Alpha particles, beta particles, gamma rays. Alpha particles, beta particles, and gamma rays. X-rays. So I think A is the right option, sir. X-rays does not come from a radioactive decaying unstable nuclei. So I think A is the option. Question number 39. A is the right option, sir. Question number 40. Question number 40. He says, what is the nuclear reaction that powers the sun? On the sun or other stars, you see the smaller nuclei come close to each other and they fuse into each other and they make a larger nucleus. In this process, an enormous amount of energy is produced. This process is called fusion. On the sun, the hydrogen and hydrogen atoms, they fuse into each other and they make helium by the process of fusion, and enormous amount of energy is given out. The fusion of hydrogen into helium. I think question number 40C is the right answer, sir. So, my dear students, we are done with this paper. This question number, let me C is the option, and we have reached the end of the, the answer is right. Okay. So, my dear students, you see, we are done with this paper. In this video, we have presented you the solution of the May June 2024 1-2 paper. I have tried my best. I sometimes make some mistakes because we don't know what is happening, and sometimes I get distracted. So excuse that. We have tried our best to provide you the solution of this paper. If you find this video useful, if you find that this is helpful to you, please share the link of this video on your social media accounts. For example, share it in your WhatsApp groups. For example, share it on your X, your Twitter, your Instagram, your LinkedIn, your Snapchat, your TikTok, wherever this is possible, share it. Because when you do this, it's a big support for me. And one very important thing is that the paper and the marking scheme, which we have used in this video, are the property of the Cambridge Assessment International Education. I have only downloaded that marking scheme and the paper from their website. I have used them, but this is the property of the Cambridge Assessment International Education. Thank you very much, everyone. It's a great blessing for me that I can make these videos and I can post them. So thank you very much, sir. Have a good day. God bless you all.